Alright, so reflection section. Reflections. So reflections are when we have a shape and we, as it sounds, reflect it in a mirror line. Okay? So you're going to have a figure, then you're going to have to show a mirror line, and you're going to reflect it. Now, you would have probably looked at symmetry as bare minimum in the past. Yes? So if things are symmetrical, it's the same one side and the other. And so reflections are symmetrical around their mirror line. Okay? That means that each point on the original figure has to be the same distance away from the mirror line as its image. Okay, so if you know what your figure looks like, you know where your mirror line is, you can count how many squares away you have to go to get to the mirror line, and then that same distance is going to be on the other side. Now, here, I've said here, the points are now labelled in reverse. So, for example, if you had a shape that was labelled A, B, C, here's my mirror line. When I reflect it, you will see it looks like that. Mm-hmm. Yes? Do you see that? Does it kind of? Yeah, so if I were to fold along my mirror line, that would sit on top of my original. Yes? Now, if I was talking about labels, this point here is this point here, correct? Mm-hmm. So, I don't know if we talked about this last lesson, but often image points are labelled with a dash. Okay? Yeah. So this B would then become B dash. This A would be over here, wouldn't it? That would be A dash. And this C here would be C dash. Now, if we look at the direction of the letters here, we're going A, B, C in a clockwise direction. Yes? Look at my A dash, B dash, C dash. They're in a anti-clockwise direction.
We need to put the dash.
You should do if you're labelling your image. Yes, because if you labelled it ABC, ABC, you don't know which one's your original and which one's your image. Okay? Right, so...
Will we get marks taken off for not doing it?
Potentially, but unlikely. Okay? Now, Jan, you have to remember, in the end, this is only going to be examined in the end of year exam. Alright? So, we are probably going to choose maybe one of these transformations. You're not going to be tested on all of them. Okay? So, it's not necessary that you need to concern yourself too much about things like labelling, just more the process is going to be more important.
Is it possible to take translation?
Yes, it's possible you can do any transformations you do. Okay? Right, now, if a point is on the mirror line, so if actually something was sitting on the mirror line, when we reflect it, it's obviously not going to move, is it? Yes, it's going to be that in the same place. Yeah. So, for example, if this was my mirror line and this was my shape, if that sat there, then when I reflect it, it hasn't gone anywhere, yes? And that's what we call that an invariant point, invariant. And so that means it doesn't move anywhere, it's the same position. Now, whenever we are measuring distances from our mirror line, I say this and some people are, oh, right, okay, so then they completely forget when it comes to it. Your distances have to be measured at 90 degrees to that. Now, for the majority of questions, as I said, here's my shape, there's my mirror line, well, that's nice and easy. However, if here's my shape and here's my mirror line, then it gets a little bit trickier. Okay? So people start to get confused, especially when our mirror lines are diagonal, because it gets a little bit more complicated. But what it means is that you just need to measure the distances at 90 degrees. So you would measure this distance here, and you'd have the same measure this way. You'd measure this distance, and you'd have the same point here. Measure this distance, and have the same point there. And there would be your reflection. Okay? But the important thing is that you're measuring at 90 degrees to the line. Does that all make sense? So when I say at 90 degrees, it means you're not going to be measuring horizontally and vertically. It's going to be at 90 degrees to it. You'll come to practice this when I show you some examples. Now, the size of it doesn't change. Okay, so the size needs to be exactly the same for both your original and your image. So I think I said to you the other day, when you're drawing these things, try and draw them as accurately as possible. It doesn't have to be perfectly accurate, but as best you can. Okay. So if one shape looked like this, your other shape is not going to be looking like this. Okay. And now some people, I've seen them do it, and it's just they just don't take care when they're doing it, and so it doesn't look good. Equally, I've seen things like this. Yeah. Okay? Does that look like that? Not really. Okay? So if you think that you are a little bit
Messy and little.
yes, a bit careless and sloppy, then you generally they are on grids, yes. But if you think, oh, I'm not drawing straight lines, then maybe use a ruler for it.
Yeah.
But I don't want you to take 20 minutes finding your ruler, making sure it's perfectly straight, drawing that line, erasing it because it wasn't quite perfect, doing it again. Oh no, I don't know. That's too a waste of time, okay? So if you can just draw it freehand, then please do. Or who are we all looking at?
They're distracting me.
Oh,
Can we have math searches?
right, you're not happy with the way it's all?
Oh,
I like it this way.
I want to have a math search.
Very human.
All right, okay, so vertical lines. Now, this is where it comes in. You need to know what the equation of these lines of symmetry are, okay? So they may just draw a line and say reflect your shape in this line, and that's great, okay, because you've got the lines there for you. But it may be a case that they say reflect this figure in the line x equals 4. And you might think, where on earth is this line x equals 4? Well, the line x equals 4, because it is an x equals, it is a vertical line, okay? So if you had your set of axes, here's your x, here's your y, they gave you this shape here, they want you to reflect it in the line x equals 4. So that's all they've given you on your diagram. You have to know where the line x equals 4 is. The line x equals 4 would be a vertical line going through the value 4. Okay? So it's not super crazy hard. You just have to remember if it's vertical or horizontal.
Where do you write that?
It says here, sweetheart, vertical lines are x equals value. Oh, you don't have to write that. We're going to do some examples, but if you wish to, there should be a little bit of space there, like I've written in this gap.
Miss Harrison, do we have to remember diagonal as well?
Yes. So if it was a vertical line, it would be the line x equals 4. Now, once you've drawn your line in, you can then reflect it. Okay?
How do you do y equals 10?
I will show you. Alright, so that's if it was a vertical line. In a similar way, we might have y equals a value. And if it's y equals a value, it's going to be a horizontal line. So, for example, y equals -2 would be a horizontal line going through -2. Okay? And obviously, if that's the case, then if this was my original figure, my image would be down here. Okay? So x equals a number is a vertical line.
Wait,
Y equals a number is a horizontal line.
do we need to actually, when it says to reflect a figure and it gives you a line, do we have to draw so we draw the line, do we have to draw the actual image again, or just the line?
Yes, you would have to draw the image as well.
Wait, how do we know if we have to draw the line again? What will it say?
Okay, so in a question, they may have a set of axes, they may have a line drawn and a figure. Okay, so if that's done and says reflect it in the line given, you just draw the image. Okay, so the line's already there, then you don't need to draw it. But if they've just given you an instruction as to which line is the line of symmetry or the mirror line, then you have to work out where it is. Okay, so if they've drawn the mirror line in for you, just reflect it in that line. If they haven't, they will tell you what the equation is.
Okay.
Okay? So,
I have two questions. My first question is, so it's always a mirror image, right?
yes.
Okay, my second question is, can I use this one?
Right now, I'm in the middle of teaching you stuff. If you're going to pee your pants, then obviously you need to go. But I would rather you try to wait until I've gone through this, because otherwise you're going to miss instruction. Okay? So obviously, if you're going to have an accident, then go. But I would, if you can hold it for a few minutes, then I can get once people get going, you can just go to the toilet. Now, a diagonal line is the line y equals x. Now, sometimes people are like, well, why is it a diagonal line? Well, we remember that x coordinates have x and y parts, don't they? Yes? So if I were to find the coordinate of this point here, that would be the coordinate 3, 3. This coordinate would be the coordinate 4, 4. This coordinate would be the coordinate -2, -2. What can we see about the x and the y part of the coordinates? They're the same, aren't they? So the x part of my coordinate is the same as my y part of my coordinate. So the line y equals x goes through the points 1, 1, 2, 2, -3, -3, -11, -11, 144, 144. They're the points that it goes through, okay? Because the x value and the y value are equal, and that's what makes it diagonal. Okay, so that's what our diagonal line would be. Now I did add this one here. Hopefully it won't come up for you, but it might. This is y equals -x. Okay, so that just goes the opposite way. So this diagram here just explains to you how to draw your mirror lines if they've given it to you as an instruction rather than on your diagram itself. As I said, hopefully they will draw the line in. Yes, Zika. But where? How far, Zika? So in a second, we're going to try and do a few reflections. So we might need different. You might want different colours to help you do the next little bit because we're going to be reflecting several different. Well, we're reflecting one shape on several different lines. So we're going to have the different positions. Cool. Okay, we're good now. All right. So this one here. I'm going to suggest 4. Okay. Right. So there's our original shape. Okay, that black L shape. That's our original. Now let's reflect it in. First, we're going to reflect it in the x-axis. Here we go. Which is the x-axis. So we're going to reflect it in the x-axis first.
The horizontal line.
Good girl. So that we're reflecting it in the x-axis. I'm going to do it yellow so that you can see this. So in yellow, it's reflecting in the x-axis. Okay. So we've said that this line here is our mirror line. It's already drawn in. We know where the x-axis is. So what we now have to do is reflect that L shape. Okay. So this point here, we've said that we have to measure things at 90 degrees to the mirror line. So the measurement we're looking at is this measurement here. So that was 1 square. Yes? So on the other side of the mirror line, we're going to go 1 square, and that's going to be our image point. Now, I'm not going to draw lines on the next set. That was just to try and help you. Because this is our mirror line for this question, so we're finding out how far away is it from the mirror line. Pardon? Yeah, so we're going to draw the shape. But I'm going to reflect my points first of all. So then I'm looking at this point here. So I can see that that's also 1 square away, so my image point is going to be here. Pardon? Pardon? No, they shouldn't. This one here, we're counting 1, 2 squares away. So we're going to count 1, 2 squares, so that's going to be down here. So here's our shape so far.
Do you start from the fair line?
Okay, so maybe me having these lines in is not useful. So I'm going to get rid of these. That was just to count far away. Well, you can have lines in. I'm just thinking if some people find it difficult. So this point here is 1, 2 squares away. So that's 1, 2 squares away. So that's here. So I'm keep joining it up. Do you see what we're doing? And then this top one here, it's 1, 2, 3, 4, 5 squares away. So that's 1, 2, 3, 4, 5 squares away. And then this one at the top is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's up here. And then I can close my shape up.
Can we color it?
Yes, of course. So that yellow one has been reflected in the x-axis. Now, as I said a second ago, if we were to fold our paper along our mirror line, so in this case, if we were to fold it along the x-axis, our original shape should sit on top of our one that we've just drawn. Okay? If it doesn't, you've done something wrong. Either you haven't folded it along the correct line, or you miscounted when you were drawing your reflection. No, so as when we were talking about our translations, remember, we counted, we rested our pen on there and then counted 1, 2. It's the same thing here. Okay, so not easy. Right, so that's our first one. Our next one we're going to do, I think, is this one here. It looks red to me. Is it red in your sheet?
Yeah.
Right, it's a vertical line. So whilst our line is there, I'm just going to test to see if you were paying attention a second ago. What's the equation of this line? Does it first of all start with x equals, or does it start with y equals? James?
Y.
Oh.
X.
Well, if it wasn't y, it was going to be x. It's an x equals. Now, we have to decide what does x equal. Which value does it go through on the x-axis? Jessica? -2. So this is the line x equals -2. Now, Abby, this is one of those questions where because they've already drawn in for you, you don't have to worry too much about it. But this is just to check to see if you remember how to find it. Alright, so our image was already there. So it's hard when there's lots of different lines, and I apologise if it's confusing. But I wanted to get as many on one diagram as possible. So this is now our mirror line, okay? So now we're counting how far away our original shape is from that line. Again, we're measuring 90 degrees to it. So this time we're measuring horizontally. So this first dot here that I've just made is 1, 2, 3, 4, 5 squares away. So we're going to count 1, 2, 3, 4, 5 squares away. Then you're going to go to the one underneath it. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and I can join those up. Now, having drawn that line there, some people, if you're very image-minded, okay, so perhaps if you're an arty person, you may look at this and go, oh, totally just draw it from that. Okay, and that's absolutely fine. If you are one of the less arty people and think, oh no, this is freaking me out a little bit, then not to worry, just keep doing what we've been doing, okay? So I'm now going to reflect this point here. So I count 1, 2, 3, 4, 5, 6, 7, 8. So count 1, 2, 3, 4, 5, 6, 7, 8. Now again, having done that one, maybe it's starting to be a bit easier to do it. And I'm going to sneakily draw the rest of my shape like that. You all happy with that? Okay?
How? You just do the middle section too?
Okay? So again, if I were to fold along my mirror line, one should sit on top of the other. Jake, what you look stressed, sweetheart.
This is very. Jake, what? Oh, you see this? Let's say. We do the green one next.
That's X because it's a vertical line, and we said that vertical lines are X equals, okay?
1, 2, 3.
Touch that picture. And then you look to see, well, which number did it go through? Well, that's obviously 0. This would be 1, 2, 3, 4, 5, 6, yes? So this is -1, -2. So that's X equals -2, okay? Right, okay, let me pause quickly.
Okay, you see that? We do green next. But I don't have green.
Alright, so let's do the green one now. Your colour doesn't matter, okay? So whichever one your colour doesn't matter. Now, first of all, as we did with the others, we're going to establish what's the equation of our line. So what's the equation of this line? Oh, no. The green one. So it's not X equals 3. Why is it white? Why did you change your mind? Well, they were straight.
Horizontal, that. Vertical is that.
Vertical is up and down. Horizontal is the horizon.
Yeah, that's how I
Okay.
remember.
So, horizontal lines are y equals, and this one happens to be y equals 3 because it goes through the value 3 on the y-axis.
Like, how do you know what vertical?
Because they've drawn it for you, sweetheart, you don't have to worry.
I know, but if horizons for horizon.
You just have to remember one.
Yes, remember one, and then the other one.
Process. Exactly.
Alright, okay, so again we're measuring at 90 degrees to it. Now this one is going to be confusing.
Yeah, I
Maybe
know.
do that. Alright, the reason this is confusing is because, look, if we were to fold along here, what's going to happen to my shape?
It's gonna fold over.
It's going to fold over itself, isn't it? Yes, so we're going to have some overlappage. Alright? Do not panic if you have overlappage. Alright? We're just going to follow our process. So, this point here, we're measuring to the line. So, how far away is it? 1 square. So, it's going to be up here.
Jay, can you even see the board?
This point down here is how far away? 1, 2. So, we count 1, 2. I'm going to join those up because I like to join them up as I go. Alright, let's do this one next. So this one here is counting 1, 2. So that's going to go to here.
I've only got one.
Oh, totally 1. I lied. It was 1. I'm talking rubbish. 1, 1. So I was just checking that you're paying attention. Totally
Or you
checking.
could have said that for counting the
I was just paying attention, make sure you're paying attention. This one here now is counting 1, 2.
Which one?
I'm doing the right hand one. So 1, 2, and so that's 1, 2. So that's up here. So again, join that up.
Doesn't matter why you stop.
Nope. Nope. Alright, so there's this portion down here at the bottom. I now need to do its stem. So actually, we're talking about these two spots up here. And so we're counting 1, 2. This time we're going down. So we're going to have to keep going down. 1, 2. So that's going to go down to here, across to here, and up to here. So there's my green in it.
Okay.
Okay, so that's my green image there. They say
Look at all of them.
they're all the same.
We only have a few minutes left.
Well, I really shouldn't have used the same color.
12 minutes left.
Can we get a test run?
In a minute, yes. Just keep going down.
Anywhere that's
Or just do the four.
It's forward, that's what I did.
Alright, okay, so that was my green one. Let's get our blue one done. Now, for my blue one, I'm going to erase my green one. Okay? This is disgusting.
You can't do that.
I know you can't. Can you still see the original?
Yes.
Okay, can you go over the original with black if you can't see it?
I did.
Don't whine.
I can see it.
But I already did.
Alright, go.
No, we're just supposed to like it.
So, this point here. Now, we said we need to measure it 90 degrees to the mirror line. Okay? So we're measuring 90 degrees. Now, that means that we're not going to measure up here, are we? Or across here. We're going to measure this distance here. Okay? Because we're measuring at 90 degrees to it. So we went through half a square diagonally. Yes? So I'm going to carry on going through half a square and it's going to be over here.
Wait.
No. And this one here is going to go through one whole square diagonally. So that's going to come over here.
How? Oh, I get it. Oh, okay.
This one here is going to go through 1.5 diagonal. So this is going to go through a half and 1.
Where's the dog?
Here.
Okay. I don't Wait, I'm really confused.
What is happening?
Alright.
That little.
Let me, given that it's the end of the day, let me
Oh, I did the wrong thing.
pause this one
The end of the day.
and